All right, I'm expecting DJ from Meta to join me up here, although he was on a panel that ran right into this slot, so I don't know if he'll get here. When exactly in the talk he'll get here. His slides are late, so we kind of planned for this. So I'm Eric Dahlen. I work for Intel and have been the chief technologist in the cloud group there for a long time. I want to talk about some of those metrics for the sustainability front that aren't being measured yet, and try to propose some areas that we need to do some work. And OCP seems like a very good place to kick off some of this and get this work going. So in the interest of time, as others have said, right, I think PUE has served us pretty well, and I'll show you kind of the trajectory for the industry average on the next slide. It's a fairly simple metric. It's easy to explain. It's the ratio of what you pull off the grid versus what goes into the ITE equipment. And as you can see, lower is better. If you had no overhead at all, you'd have 1.0, right? Every watt you pull off the grid goes into the servers. That's not really how it's ever going to work, but you can see when we started measuring this, so the green grid kind of popularized this in 2007. So it's been about 15 years. But most of the improvement as an industry average happened in the first 5 to 7 years, right? You get 80+% of the benefit you're ever going to get. And this isn't reflective of the best-in-class numbers you've heard of, right? Some of the flagship hyperscale data centers are down in the 1.1 range, but you can imagine, the hyperscalers also are operating over 100 data centers in 40 different countries, and the fleet average isn't 1.1, right? The fleet average isn't 1.5 either, right? The hyperscalers do tend to do a little better than this, but as an industry, there's lots and lots of data centers, and they've been proliferating. And you can see this is pretty good progress, but this is only part of the stories, right? So not only has progress kind of stalled here, but as I'll show you, there's an awful lot of efficiency that's not reflected here, right? So you can think of efficiency as like 1 over PUE, right? And by that metric right here in the top section, if you're at 1.1 PUE, you're 91% efficient, right? The inverse of PUE. And you're at diminishing returns when you're at 1.1. But there's a whole bunch of overhead after you get power to the ITE equipment that isn't accounted for yet by PUE, right? And here's like 3 broad categories, right? Conversion losses, you come in at high voltage AC, you got to convert to low voltage AC, and then convert to high voltage DC, and then convert to low voltage DC at the point of load. And all of that will probably lose closer to 20% than 15. 15 is pretty charitable, right? And then we have energy attributable to cooling and infrastructure management, but not to the actual effective service capacity, the work being performed by the data center. And that, that thermal kit and overhead energy has been ramping. And that's a function of heat density mostly, right? As the components get more powerful and hotter, the cooling power starts to ramp too. It turns out that when you try and change the case of an integrated circuit with flowing air, the fan power to move the case temperature is a cubic function, right? So the power on the fans grows very, very quickly. And then a third thing which has been observed, but we don't really have our arms around it yet, right, is the idle power of the system. When the system is ready for work, but no work has been scheduled yet, right? All the systems are on, a whole bunch of software is loaded, network connections are up, devices are spinning, ports are active, but the load balancer hasn't shipped the first job yet, and you're probably at 30 to 35% of your peak your peak measured power already before you do any work. And so that idle power, if you account for that, right, as inefficiency too, you have more than 50% net overhead. And I have an example in here that's based on the current the production racks right now for OCP with the Generation 2 power shelf in it. And I'll talk, this is an eye chart, so I apologize for that. The whole point of this slide is to get to on the far right, some proposed areas for work, right? So one set of observations here is about does the data center have to be as big as it is, right, in terms of its provision power and its space. The AC design max for PowerShelf 2 is actually a 13.2 kilowatt rack, but the AC load limit, right, the operators at Meta are trying to keep the active power below 11, right? And if you go look at the actual rack power utilization, the average out in the wild is about 9 kilowatts of rack power. And so this model shows 8.6, so you're basically at 65% rack power utilization, meaning, one way to look at that is you have about 50% more racks than you should need to have for the amount of capacity that you're sustaining in that data center. So that's one area for optimization. Another, which is probably more on my topic, right, is the net energy efficiency. If you account for that idle power overhead and all the thermal management and all the conversion losses, this rack, even though it's in a world-class data center with a 1.15 PUE, the overall efficiency is below 40%, right? And if you think back to that chart I just showed on PUE, when we first started measuring that, 40% is 2.5, right? So it is the bad old days. We're right where we started kind of in PUE, and I hope we can do the same thing, right? I hope we can get 80% of the benefit out of this in the first 5 years just by standing up some standard metrics and starting to focus on getting the efficiency up, because all the stuff about sustainability is all valid, and we'll talk more about it. But obviously the most sustainable watt is the watt you didn't have to burn. So if we can get a higher fraction of the watts doing work, we'll burn fewer total watts, right? And then we can talk about using renewable energy and getting our scope 1, 2, 3 down and all that good stuff. So this leads me to kind of propose that some of these are already going, right? So we already have a work stream on liquid cooling. Obviously we can improve PUE and we can go to higher temperatures and densities and make the data center smaller with less material in it, fewer hotter racks, with more efficient cooling and less cooling energy overhead by going towards immersion, right? Liquid assisted and immersion eventually. So that's a work stream. Obviously the power delivery work stream, there's been a lot of work, a lot of great innovation done here by OCP already to try to get the conversion efficiency up. And more also important, get the conversion efficiency up at the point of average operation, right? You don't like report the best number you could ever see and it only happens at peak load, which never happens, right? Clouds are provisioned for a peak that you seldom experience. And they spend most of the time down in the sub 50% utilization level. So that's where we need to measure the efficiency of the system, and that's where we need a local maxima at the operating point. 5 minutes, okay. And then obviously rack utilization is something we should work on. If we can get the utilization up on a smaller amount of infrastructure to meet our supply, right? So that scalability, and we can talk about, when I'm off peak, how do I optimize the power efficiency for being off peak? There's a lot of room for innovation there. There are reasons we don't do some potentially obvious things to save power, but with innovation and real engineering, I think we could do some of those things and get the efficiency much higher, lower in the load line. And then idle power tuning, which is something I think Meta has kind of trailblazed on. A year ago, a couple engineers from Meta were up here talking about this, where they go look at that, the cloud software platform is loaded, but the work isn't scheduled yet. When you try to do a production release, if you've made that power go up, you got to go get another rock and try and fix that. And most companies aren't doing that. There is no, we don't have a standard metric that shows whether you're winning or losing on that. But ideally, we get these things to be, reported in kind of a real-time manner so that if you try to optimize your software and your stack, you can actually see a difference in some metric. You can see a metric improve. And so that's kind of the work area. I'm starting to get into DJ's material here. So beyond PUE, above and beyond energy efficiency, we talked about some of this, right? We have to decarbonize the grid, right? And so factoring in renewables, making it possible to measure, how effective it is to try to time shift and geo shift work to where the energy is greener, getting the operational energy efficiency up, which is what I spent most of my time on here today. And then getting to circularity and management of embodied costs, right? So, all the other attendant sustainability metrics like water usage and all of those things, we also have to, create a circularity index, if you will, or these kinds of things. I think our friend from Schneider was talking about a paper they put out that proposed somewhere like 23 metrics. I'm not sure how many of those we need to adopt, but there's a few handfuls of metrics that if we started to standardize how they're measured and get them published so that we can start to focus on them, we can make a lot of progress, I think, in a relatively short period of time, and then get to that, trying to grind out the next 10%. We got to get, there's a lot of improvement between where we are today and that point. So some ideas to think about. So this cartoon is kind of, I think you can think of this dashboard as something that we'd like to enable someone to build, right? A dashboard where you can see, your energy and your carbon as a real-time metric, right? Where you could do a 6-month trailing thing and report it. You could track it. You could try to optimize it. You could change your operational parameters and policies to try to improve how you're doing with what's available to you today. We need this kind of thing in front of, all the operators and in front of or factored into the automated systems that are increasingly used to schedule and optimize the work. And so there are multiple proposals like this in flight that I happen to be aware of. I think we need to work on those and contribute to those from inside OCP. I'd like to see better connectivity, I think, between these groups and those groups, right? So, and this extends into the software realm as well, right? So where we've been, right, because these aren't standard, even PUE, right, there's no standard for how to measure it. Is it a 6-month trailing thing or an annual thing, or is it like the best number I ever saw on paper, but I never actually operate at the point that I report? There's no real enforcement or alignment on what it is you report when you report PUE. And I think, there has been enough motivation that the PUE number is generally available. I think as we create these other metrics and we all adopt them, we also need to think through and make part of that effort being, how are they going to be reported, right? What is the auditing process? They need to be easy to understand. It shouldn't create, a huge burden on operations to be able to measure these things. But I think, it should be, a valid and meaningful thing to compare, last month to this month and this geo to that geo and one company's implementation to another. Right, so we'd like to see fleet level metrics. We'd like to see, metrics that can be extended, I think was alluded to in the prior talk, not just in the hyperscale core data centers, but out through the points of presence out at the edge and into the far edge, as we've seen, with there's a whole lot of IoT and mobile device new use cases that are amplifying the capacity out at the edge of the network. And those need to be accounted for too. I think we can't do it here first and then account for those later. I think we got to account for it all as we get going. So I'm getting the hook here, so I'll jump to our call to action slide. Lots of work to be done here. I think lots of improvement potential, right? I think we can make a very big difference in a very short period of time by getting some focus on these. There's obviously lots of room for us to do better. So please reach out to DJ or to myself. We'll have more information up under the sustainability initiative that you just heard about that got kicked off here going forward. And you can expect to see some work groups proposed and hopefully stood up and starting to run within the next couple of quarters. I don't think I left much time for questions, but thank you.
If I could ask one question, as the next speaker isn't up yet.
Certainly.
Yeah, it was on your bar chart slide on the left bar, you showed a measurement that I've never seen before, which was the AC PMAX buffer.
Yes.
Could you explain that briefly?
Yeah, so that was on the left side was the design point. And what we've seen is because of DIDT and inrush currents and the ICC max of these very high powered devices, there's an empirical limit of AC load beyond which you don't want to operate. So even though the racks are designed to support 13.2, the operations guys are very careful never to operate them above 11. And that guard band, it's not really an official thing. It's an empirical thing we backed into, which also isn't measured. But obviously we need to get that guard band down. And some of that's our fault, right? Arguably, I'm at Intel. The biggest DIDT is us, right?